Okay, this is 8.4 trigonometry. Continuing on, this is the B portion, the second video. Continuing on with de Moivre's theorem, powers and roots of complex numbers. So, every non-zero complex number has exactly n distinct complex nth roots. So, for example, if I have a complex root like a plus bi, and I'm taking it to the third power, there are going to be that many complex roots. Every non-zero complex number has exactly this many complex roots. So whatever that n is, whatever that exponent is, that's how many complex roots we're going to be able to come up with. Alright, so you're probably not concerned with all the mumbo jumbo as much as how in the world do I find them. Alright, but it's nice to know how many there are. So if we have 8 times cis 135 degrees, alright, or 8 cosine 135 degrees plus I sine 135 degrees. Okay, let's say that we have that right there. Alright, so what we're saying is that there is a formula, or there is a complex number that whatever we take, so let's write this complex number and let's use alpha as my angle. There is a number that if I take this and cube it, I will get that. Okay, so that means this is, there are three, let me say that again. If I multiply this whole thing times itself 3 times, I will get that. Alright, so let's put it in a form that you better understand. Basically what I'm saying is that those two are equal. There is a number that if I cube it, I'm going to get this. There is a number that if I cube it, I'm going to get this here. Okay, so this is my my cubed version right there, my 8. That's what this whole thing is. And so I'm saying what number times itself 3 times will give me this. Just like I'm saying, what number times itself 3 times will give me 8. What huge mess here can I take times itself 3 times that will give me this huge mess? So hopefully that kind of makes sense there of what I'm doing. I'm giving you this. I'm asking for this. So I'm saying, given this, what is the cubed root of that? And that's this number here. Given this, what is the cubed root of it? So this is what I'm looking for here. And there are going to be 3 numbers times itself 3 times that are going to give me this. 3 different options. Not true with this. It's just a 2 cubed is going to give me 8. So it doesn't work the same when we're dealing with this. But so hopefully that makes a little bit of sense. I kind of feel like I'm being confusing here. So let's say it again. What we're looking for is what number times itself 3 times is going to give me this. And I'm giving you this, and I'm looking for that what number cubed is this. So I'm taking the cubed root of this, and the cubed root of 8 is 2. So what I'm going to be doing is basically this. And then when I do that, I get 2. The cubed root of 8 is 2. So dealing with complex numbers, I'm dealing with a formula. So I guess the key thing that I'm trying to get you to focus on is, given the answer, I'm trying to find the cubed root of that answer, which in this case is going to be 2. Given the answer, I take the cubed root of that, and I'm going to get this here. So this here cubed is going to give me this back. So I will be quiet and kind of let that sink in. Okay, so I have a tendency to skip a lot of the theory, and that would be stuff on the bottom of page 353 and the first 3/4 of page 354. I'm going to jump right down to the nth root theorem, and it was kind of developed above on page 354, but not a whole lot. It was more of an example. So I'm going to give you the theorem here, not necessarily going to be able to explain it without actually doing a problem. Alright, but let's see if we can kind of give you an idea of what's going on. I don't really use this, and I don't really use this. Okay, so if you can take this here and this here, that'll be what we do. Alright, so let me tell you the difference between the two. We are trying to find an angle, alpha, based on our given angle, theta. And because this says 360 degrees, this is if we're trying to find the roots in degrees or in trig form. And this is if we're trying to find the roots if we're in radians rather than in degrees. So there's the radian form, and this right here is the degree form. So that's the only difference between these two. So notice we have 360 degrees, and down here we have 2 pi, which is the radian form of 360 degrees. That's the only difference between these two. Everything else is the exact same. So it's really only one formula. It's just one is in degrees and one is in radians. Alright, so we'll do one of each. Well, we'll do several of each in order for you to get this down as far as what's going on here. Alright, so I'm going to go ahead and copy and paste this into the next video since I'm already almost 7 minutes into it, and we'll just do some examples.